Good morning, good afternoon, everybody. Welcome to the first webinar of the UNICC Webinar Series. I'm Franca Vinci, Head of Learning Services at the United Nations International Computing Center. I'm pleased to announce that UNICC will deliver a series of one-hour monthly webinars over the next months on several topics related to digital technologies. Being the UN IT provider, digital provider, the aim of this series is to promote digital insights among UN personnel in line with the UN 2.0 vision. So UNICC will leverage the internal technical expertise to introduce, explain, even contextualize innovative technologies and solutions within the UN environment. But we also will rely on the expertise of external distinguished guests, like is the case of today. Our attention today being the period of big talking buzzwords about ChatGPT Copilot, we thought that a good start could be artificial intelligence and its applications. I have the pleasure to introduce two distinguished speakers and experts, Dr. Andres Fortino, Clinical Associate Professor at the New York University, and Mrs. Anusha Dandapani, Chief Data and Analytics Services Section at UNICC. Just a little bit of information of who our speakers are. Dr. Fortino is an international recognized educator, researcher, author, and transformative leader in higher education. He teaches graduate courses in artificial intelligence, business analytics, data mining, research methods, and more. Anusha Dandapani is responsible for creating and overseeing the growth of data and analytics services for UNICC. Anusha advises and partners with other UN organizations, industry, and academia on solving their business problems by leveraging artificial intelligence, machine learning, data analytics, data engineering, data science offerings, and capabilities. Before leaving the floor to our speakers, I would like to invite you to use the meeting chat for any question or comments during the presentation. Take the chance of the expertise and the practical knowledge that they have on the application of these technologies to raise any kind of questions. And our speakers will be pleased to address them during the last part of the webinar. So without further ado, I leave the floor to Dr. Fortino to start our webinar. Enjoy your webinar.
Well, thank you very much and welcome all of you to a very, very important topic, what we might call today the elephant in the room, an expression in English that says that we have to pay attention to it. And I'm glad Ms. Dandapani chose to lead our series with this very important topic that is so transformative. Thank you, Franca, for that great introduction and to all your colleagues. So we're going to cover some of the basics of what we call generative AI and differentiate that from what you're probably familiar with, what has been called AI, which is data analytics and machine learning algorithms that are been serving us in other areas for quite a while. The generative AI has been an approach that has yielded many, many powerful and transformative situations for us, as you will see, because Ms. Dandapani will cover how it has been used in transforming IT and IC recently for you guys. Then I'll show you how it could apply to leverage everyday work and how it's transforming the work environment in many industries. I'll quickly give you some statistics of that, but I want to rush ahead after that. I don't want to spend too much time on it because the more important thing is applying it in your situation. That's the key thing. And I'm going to turn it over to my colleague at that point to speak to what they're doing at the UN so far, the UNICC, and applying this very a crucial technology to making things more efficient, more effective. And then turn it over to have your questions on to how you can apply it yourself to make your work more effective and efficient as well. So without further ado, next slide. We'll cover understanding AI, as I said, some of the core components. I'm not going to get too technical, but just give you kind of an overview of how this is different from some of the things you may be familiar with, data science, machine learning. It is a type of machine learning, but how it differs because it is accessible now. It's been democratized to staff who don't have to be data scientists, don't have to be deeply knowledgeable scientists, data scientists, or analysts. And then this makes it accessible to quite a few people. And then we'll discuss how it applies, how the organization has matured in its application of this, where it is today, the tools and skills, and then applications so far, and then how to go about implementing it in your own work. Next slide, please. So I want to make sure that we understand that artificial intelligence is used as a broad term. It covers many, as you might call, sins, right? It's a simulation of how humans apply intelligence, how their intelligence you could see it how it applies, and we're trying to build machines that emulate and go beyond human intelligence, and it's a good thing, and it's got some issues that we will be discussing. But you got to do it carefully. You have to do it properly. It does do a lot of the tasks that humans do right now, not only thinking tasks with your brain, but also the use of other neural elements such as vision, hearing, and speaking. So it actually does a very good job simulating all of those functions, cognition as well as vision, and these days it will start emulating how humans interact with other humans by taking on roles that are speaking roles and so on. One of the foundations for the artificial intelligence that we'll be investigating as the game changer, generative AI, ChatGPT, Claude, and many of the other tools that are available out there, is a form of machine learning. It is based on one form of algorithms that are developed by data scientists that learn with data. So it is a machine learning environment of a unique kind, but it has gone beyond the uniqueness of machine learning to make it a more general tool. It has the ability, yes, because it's based on natural language processing, but it goes beyond natural language processing. It can generate images, it can generate voice, it can generate music. It has many other capabilities that are fundamental to the way that the type of machine learning that you will see in a minute, it actually has been implemented. So natural language processing, computer vision, and based on a very sophisticated, expansive machine made up of computing components, as you will see, on a vast scale, trained on a vast scale of data. Both of those components are what makes it a key advance today. Next slide, please. Quickly go through history. We've been at it for 70 years since we discovered that we could simulate the action of a human neuron, a nerve element that has the nucleus, and it has an axon, and it has input that comes in through dendrites on one side, and then it gets triggered, and then it has a reaction, and maybe it triggers other nerve cells. We came up with a computer model of this neuron 70 years ago. We were looking towards the one day, perhaps, it folded into some machine that could pass the Turing test, which means it's indistinguishable on the surface from how humans would interact with humans. So we can interact with a machine, and it's indistinguishable from interacting with a human. That was the test that has stood the test of time for quite some time. Now it's kind of a deficient test because machines are able to fool humans into thinking they're talking to humans. So we're looking for other tests, and there've been other tests to say, where is artificial intelligence going, and how can we gauge its advance, its progress? Like Turing test is no longer a useful measure of capability for this tool. In 1957, we discovered and proposed a computer model for the individual gate that at the end today will become the element of this vast machine that we call a neural network. Again, it was a computer program that had inputs. It had output based upon the inputs, and it was programmed to be triggered to have an output under certain conditions. And they added another element, which makes it a very key element, which is a weight that allows you to come back and not only look for inputs, but also to adjust whether it would trigger at all. It would trigger at all. So the weights made it a very interesting type of computer program. Little tiny cell of a program that was the key cell. For a while there in the 70s, no advances in artificial intelligence, if you will. And by the 1980s, we began developing expert systems. Today, it's real easy to put together an expert system with generative AI. I've done that with my students. We do it all the time. But in the 80s, it was very difficult. You had to program each one individually with all the rules. You had to have experts to weigh in on it. And it took a lot of work. And they were okay, but we didn't do very much with them. Again, in the 80s, we had another hiatus. And then by the time the 90s came around, we began having now the foundations of what is today the powerful generative AI platforms, the large language models, which is the interconnection of these perceptrons, the little tiny programs, into a very large machine that could be programmed to with the weights and the connections, that could be programmed to respond to input requests, process those, parse them into inputs into a large, very interconnected large matrix of these machine neurons, perceptrons, that then could also, once they, with data, were able to adjust how they responded and had outputs that look extremely like a brain taking input through hearing, through eyes, through reading, a brain that has been trained to understand words and understand language, and then process it to come out with an output, and the human brain will come out with a response. And this deep neural network created so that they could do that. It could actually emulate the activity of the brain in that sense. And when it came out with outputs, we used a very sophisticated way of coming back and saying, those outputs, some of them don't look good. A human would get involved in giving the machine feedback like you raise a child and tell it, don't put your hand on that stove. That you'll hurt your hand, right? So you gave the machine feedback that output that you just came up with, that wasn't a good answer. That's called human reinforced learning. So the humans, that's why it takes so long to train some of these platforms, a year, maybe more. And the weights get adjusted for each of the perceptrons to say, that way out of the maze, because it is a probabilistic shot in the dark that it does. Oh, maybe this is a good answer. And it comes out with something and the human says, nah, not so good. Every time you interact with ChatGPT and you tell it that wasn't such a good answer, it actually uses as feedback to adjust the weights on its perceptron matrix to be able to say, that's not a good answer. Next time we don't use that. So it has a way of learning on the fly, so it is machine learning. It's a machine, very sophisticated machine, deep neural network. It's called deep learning because there's so much amount of learning that happens. And so now we are with this tool that has an input set of perceptrons to receive your request, normally done in natural language, which is so cool, so wonderful. It parses it into what it needs to be able to process it with this matrix in the middle. And then when it gets an answer, it actually takes all of the output from the deep neural net in the middle and begins transforming it into something that's what's called transformative. It generates an answer that a human can understand. It actually, this is the UN, so you have people from all over the world with many different languages, many different cultures, and it adjusts it to the language and the culture of the speaker by the way you request that it present it to you. So it is a very sophisticated machine that does a lot of things, a lot of things. And today, we're wondering, have we gone too far, right? Is this machine with the data has been trained, human data that was put in there by humans, created by humans, has biases in there. Perhaps the machine, not knowing any better because it is a machine, it spits that stuff out that has with biases that are inherent by the nature of the data. So we have to worry about, is it doing a good job? Not propagating biases of humans, where they continue injustices and things that are not quite good that we know that humans should stop doing. The machine shouldn't continue to do those things because we've empowered it with the data to do that. It doesn't know any better. So we have to put in curbs ourselves. So we're in the mode right now with things like the European Union passing regulations on let's be responsible with it. So we're grappling with putting guardrails and boundaries. But it is a very powerful tool, and we'll talk about it next. Next slide. So I want to make a difference between what I call artisanal AI and generative computing, cognitive computing. Artisanal AI are things you're familiar with. Many of you are in IT, many of you are in the data analytic world, and we've made great progress from descriptive analysis, statistical analysis of data to give us some results to know what's going on, to now using some sophisticated algorithms for predictive analytics, what we might call data analytics, data science. We build these machines from scratch. We take an algorithm and linear regression, decision trees, these very sophisticated tools that can help us extract answers from data and predict what the future will bring. Those are built one at a time, laboriously with Python, R, and many other platforms. You're familiar with these. We call artisanal because they're like one-off. And they're very, very important and very powerful. We'll continue to build those because they're specific to a specific purpose. But if you want to process data to get answers in a general way, and even today have the computer build Python programs for us because it can do that, we switch over to this deep neural network machine, because it is machine learning, that has been pre-programmed with a lot of data to perform very general functions. We call that cognitive computing because it's starting to look like it without a lot of effort by the requester. You don't have to become a computer programmer. You don't have to become a computer programmer to be able to extract answers from data these days, because this machine is there with its power, with a few prompts, being able to give you some very sophisticated results, right? So it's based on parsing language, the requests and the data that's been put in there. The data sets are enormous. All of the world's data on Google, for example, and all the world's literature. That size of data sets, expansive. And the good part about it is it's accessible to less skilled staff. What do I mean by that? Folks that maybe have a little bit of knowledge of Excel, but nothing beyond that couldn't do predictive analytics, couldn't do data science, don't want them to do that. Yet they can produce results by querying it properly, right? Without too much effort, without too much skill, and get results that are equivalent to what it used to take data analysts a lot of time to do. Even data analysts are using this now to be more productive and produce results faster and sooner, because the machine will produce Python code for some of the requirements of artisanal AI work. It is, like I said, based on neural networks. We have a number of these built by large companies because it takes a lot of effort, a large group of people gathering a lot of data and huge machines to program these neural nets in a way that is productive to do this. But at the end, you have these, what we might call cognitive computer or knowledge robots. Robots, not physical robots, but robots that can assist us mentally to do mental tasks and be our assistants to give us an aid to perform our cognitive work faster, better, more efficiently. Generate images, amazing images. Generate short videos, interesting, but mostly it's about language, generating, understanding language, summarizing things for us, extracting information from it, and very creative and giving us alternative avenues of thought, right? So we can ask for and request different viewpoints on a paper or a subject or a topic or a strategy that we might be thinking. And that gives us a opposite point of view, a complementary point of view, and it makes our work more valuable, more deeper, and more effective. So cognitive computing, artisanal AI. We'll still continue our efforts in artisanal AI because some of these are very needed, but much of the work will be in the area of using cognitive computing to enhance our everyday work. Our work will change. The jobs will change as well, but the work will change to be aided by it. Let me give you a metaphor, and I've used this, and we'll use it again. That's fine. Metaphor is, farmers 250 years ago would follow a donkey with a plow, and they would plow a field and only do so much work because everything was manual. And then 100 years ago, Industrial Revolution, we came up with motor vehicles. Those motor vehicles for the farm were turned into tractors. Now the farmer now can plow a lot more fields, be more, that's the work that the tool that we gave the farmer, a machine that would help them become more productive, more effective. And the work of agriculture remained. You could produce more food, right? Interestingly, the work of the farmer changed from being just a farmer that plowed and harvested and knew the land and did his farming thing, continue to do that, but that was a smaller portion of his work. Now the work shifted to, now you have to maintain the machines. The farmer had to become a mechanic to be able to, because you don't have your garage right next to your farm. It was too far away. You had to know how to use these tools and repair them and keep them up going. So the farmer had to change skill. Farming was still there. A lot of farmers. Farming job continued, but with a new tool came new ways of working and new approaches. Next, let's talk about generative AI. What does that mean? Generative AI. Okay, it's a system that can generate new content that has, it's not pulling something out of the library. It's not going to the library and saying to the librarian, I need a book on this topic. Librarian goes, gets the book and shows you the book, and you look at the content. This thing generates new content. It makes stuff up. Some of the stuff is very valuable. It's actually very useful. It actually gives you other points of view, perspective. It can actually modify work that you've done, make it more grammatical correct, propose changes to the way you express yourself that makes it clearer, makes it better. So for me, as a second, as a English as a second language immigrant to the United States, my English was terrible because I knew Spanish. I use this tool all the time now to make sure that my English is more clearer than it used to be, right? So it's improved my communications, for example. So not only does it help create new content, but it actually helps you with the content you're creating. The same thing with images, creating audio, creating video, but images and text, the foundation for a lot of creativity, marketing, communications. That has been a boon to that part of organizational work. They're called foundation models because the foundation models are the ones that are built with a lot of effort over many years, with a large data set, with a very large neural net. and owned by a company, OpenAI, Anthropic, Google, and a number of other companies around the world who have invested into creating these very large models, training them, and keeping them updated with new technology as it comes in, more data, and so on. They're called foundation models. And those are the ones that are the basis: ChatGPT, Claude, right? Those are the kinds of models that Copilot for Microsoft, those are the kinds of models that we call foundation models that are available for our use. Now, companies, you and Mike, and some companies do, McKinsey developed its own foundation model on its own information, 200,000 documents that its consultants have produced over the last 50 years of consulting with company. You put that into a database of just that as a foundation for future consultants to query, what did we do about this? What did we do about that? How could we, in a new situation for a new company, use our knowledge and extract it? And this machine will produce fantastic results for it. So companies can produce their own with a lot of effort, with a good reason. So that's kind of artisanal building generative AI. Most of the models that we use as a service, kind of like having Google, right? Having the internet, and you build websites on the internet. But you don't build your own internet unless you need an intranet. But most of the time, you use the cloud that's publicly available. Same thing here. These foundational models are publicly available. They generate human-like outputs based on human-like inputs. We no longer have to program in a very strict, error-free way like Python, R, C++, any of those languages that some of you may be familiar with. We can just prompt it in natural language, English. Just ask it naturally. Very specific instructions, but in the English language. And you can try a couple of times until you get the output you want, right? So it actually is very forgiving. And at the end, you say, oh, I got what I wanted. This is great. Great creative tasks, and we'll talk about some of those tasks in a minute. Examples of these tools are ChatGPT, DALL-E and Midjourney for images, and then computing is fantastic for computing because it will actually, you ask it to, here's some data, analyze it for me. It will actually create its own Python code and run it and give you an output based on its Python code that it created to analyze it and give you an analytical result. It's very, very, very powerful. Next slide. So generative means it generates output based on prompts. It often is something other than what's in its training set. In other words, it doesn't regurgitate things. It's not a librarian bringing back a book. It actually generates new text, generates output that is unique, that is different. It is part of artificial intelligence because it's artificial and is very intelligent, cognitive computing. It's called pre-trained because the foundation models have been built and trained separate from being put to use. So they're pre-trained, and you then use them once they're trained. And they're transformers because they transform your input, which is in natural language, into the language needed for the deep neural network, the tokens that are processed by the perceptrons in the net, and then transform it back out to something a human can understand in its own language. It's a transformer because it does this transformation from the human world to the machine world back to the human world. And it has a number of components. I don't want to get into it, but I think I'm giving you enough of a vision of how this thing might work that'd be enough to give you some understanding. Don't want to look under the hood too much. Next slide. So what are we talking about? We're talking about a radical change in the way we work. Just like 200 years ago, we had farmers, and then the industrial age came about, and it produced things to help the farmer change his way of working. The same thing with the information age. 100 years ago, almost 100 years ago, we began creating these computing machines, computers, and yielded our, probably the peak of that been the internet, being the global network information network. Those things change the way the civilization did its work in the era before. So information technology changed radically how we did the industry work, manufacturing, and even some services. Today, we're at the cusp of making the same kind of transformation. The work with these generative AI, which is just at the beginning, will transform even the way we do information technology. The work of the knowledge work of last century. Right? So we're at that point where all of the work is shifting to a higher level because much of the work that was done by hand, clerical work, staff work, analytical work, is now being relegated to machines under our direction, right? Under our direction. And you now can actually create and perform many more tasks. Before you had to do it by hand, so you could only do so many in a day. Now we can do many more tasks, and we can do them at a higher level. And now that we have these tools, these assistants, we can do a lot more, be much more creative, and there's no end to the kinds of things that we will create to make the world a better place. Hopefully. Okay. So I recently, next slide, just real quick to give you an idea. I recently did a study of occupations to say, well, people are saying, well, jobs are going to disappear. Yes, they've always disappeared, right? 90% of Americans 200 years ago were farmers, right? Today, only 2% of Americans are farmers. The job has changed, right? There's no many farming jobs there. And the job is completely different than it used to be 200 years ago. Indeed. So if you look at the jobs today, as put together by the Bureau of Labor Statistics in the United States, many of those occupations have been classified as the services occupations. Just a few are agricultural, industrial, other than services. I've taken a look at those services to say, well, which one of those are going to be affected by these cognitive computers, what I call knowledge robots, that we're going to start using in a major way. And you look at it, many of those services, traditional classified occupations, can be considered knowledge occupations. So I changed from services to knowledge or services, and it turns out to be about 58% of all of the occupations are knowledge occupations. Those are the ones that are going to be most directly affected by this revolution in AI, the cognitive computing, generative AI type of tools, right? So we're talking about a large portion of the economy now is going to be affected by the way work is being done. Jobs are changed, yes. Jobs will be lost, new jobs will be created. I'm not so concerned with the loss of jobs because we lost a lot of farming jobs, yet we gained a lot of industrial jobs 150 years ago. Same thing with knowledge workers. We have very few people working in the factory today. We lost a lot of factory jobs, but we gained a lot of knowledge work jobs. That's like 50, 100 years ago. Today, we're going to see the same thing, I'm thinking. And the jobs that are going to be affected by the nature of the work changing, job descriptions will change, job positions will change, new jobs will be created because of generative AI. So we have to look at what is AI, how is it affected? Next slide will give you a quick picture of that. And as I teach it to my students, I say you have to move up from doing the specific jobs, being a researcher, being an analyst, being a writer, to now using these tools to help you do those things faster, better, employing the tools. So you are now like a supervisor of a team of these robots, these cognitive robots that are performing these tasks for you. You have to know what they are. You have to know when they get off the rails. So you have to keep them on guardrails so that they do a good job for you. Know when they're not giving you good output because there's still some glitches in the technology. We have to be aware of it and stay on top of checking them, But robots that keep you, if you were a manager, you would have a whole staff, team, personal assistant, keep your meetings and your schedule and organize things for you, connect with people, and then manage And then you have data analysts to help you with your data. You have project managers to help you with your projects. You have computer programmers that will build your, artisanal AI. You have writers that will create things for the web for you. You have people who will go out and find information for you, bring it back. And you have staff people for doing all kinds of things. And you need to gather this team, costs you money, a lot of effort. Now, as a staff person, you have tools as your manager had people to do these things if you wield them properly, to do research for you, to code for you, to do data analysis for you. You're going to be a one-man band, so to speak, right? Or a one-woman band, with a lot of this stuff being done by these robots that are generative AI based, and you've got to be knowledgeable how to use them and skillful in using them. Doesn't take too much. That's the good part about it. Very democratic in that it's accessible to a lot of people. Again, you program them in natural language. So this is where we're headed, having lots of these tasks being performed for regular everyday knowledge workers by a new tool if it's used properly. And we're very excited about this. So I think my next slide is where I turn it over to my colleague. And I'm sorry, Anusha, I didn't leave you very much time, but let's see.
No worries. I think, Andres, you set the stage well and also added a context to our sort of audience to understand there is not only ray of optimism, but there is a lot of sort of hope that this artificial intelligence, the revolution that we are in, kind of is going to give us more opportunities to create. Yeah. So from our perspective, Andres, and also colleagues who are here in the audience, the way we see artificial intelligence imbibe into the culture or imbibe within our organization is that there is this concept of maturity that we got to understand. Yeah. So yes, of course, we are in the eye of the storm. The AI revolution is getting faster than what we imagine for the organizations to keep up with. But most of the organizations tend to forget that the technology is one of the pillars of the operating model in all organizations. People, process, and data are also part of the revolution that we are going through. Yeah. So more or less, most organizations are still at the level of maturity, what we call as a transactional maturity, something between manual and foundational, is where most organizations are, because now that artificial intelligence has come into the existence, we are able to augment certain processes. We are able to automate some of the workflow and the capabilities within the organization. We can also apply standardization and sort of widely used principles using technology. So where we see heading, where are we all going, is that we are becoming more automated. And what would this imply to organizations is that we will all become insights driven in our decision making process, where data science will start augmenting our decision making process and also help us exceptionally perform certain tasks that are repeatable, certain tasks that will take the time away from the time that we dedicate to do these sort of tasks. So where we are heading from a transactional part of the maturity of an organization is we are becoming more strategic in how we see things, how we use these sort of tools within the organization. Yeah. Yes, of course, there is this hype cycle that has been thrown at all of us that like, hey, we are in this phase where AI revolution is at the peak. The expectations are high. We are expecting for this AI to take away our jobs and whatnot. But as Andres rightly pointed out, the evolutionary life cycle of this kind of technologies, they do go through an S-shaped cycle. Yeah, there is always a plateau that we reach, and it becomes a new normal for us to have AI in the workflow, and it becomes a new normal for us to have intelligent applications and intelligent system enabling the work that we do. So that is this hype cycle that Gartner also sort of forecasts, and the expectations are that it will become the new normal for us to work with AI supporting us in our workflows. Yeah. So what are the tools and the skills that we see that we are also augmenting ourselves with? Like, most of the academic institutions right now are sort of adding these components of learning data science and understanding data, and also understanding AI as part of the content, not only because of the revolution that we are in, it's also because some of these tools and the capabilities that we can bring to our organization also comes along with the skill of using the tool, right? Like, some of these approaches of natural language processing or machine learning or process automation, you definitely need a specific category of a tool to enable you to do the customer analytics or understanding the sentiment of your customer, or trying to understand what is the data that we need to validate in order for us to validate the workflow. And also using generative AI for certain kind of use cases that are pertinent to our organization. Like, for example, the conversational chatbots that we are currently deploying and currently experimenting with, and the content creation component of generative AI, where we are able to produce reports that usually used to take like 3 to 5 days for us to create the content together. So these sort of tools are not only increasing our productivity, they are also reducing the time to impact of how long it used to take in the past to how long it takes for us to get to where we want to get to now. So these are some of the tools that enable us right now in the work that we are doing within the UN ecosystem. And when it comes to the capabilities itself, right, like, we have to understand that the evolution of us adapting to AI has this component of descriptive, diagnostic, predictive, and prescriptive. So not all AI needs to be predictive. Not all AI needs to be prescriptive. So there is this component of the evolutionary life cycle of how AI helps us in reporting, how AI helps us in enabling us having self-service reports, and also how predictive modeling essentially gives us the operational and also business-driven decision-making capability, to prescriptive, which gives us the operational, not only the operational, but also the simulation and the optimization capability. So these are some of the capabilities that data science and AI is an interchangeable terminology. Correct me if I'm wrong, Andres, because everything evolved from the concept of understanding data and the data science function that has evolved into what we call as the AI capability right now. So without further ado, I want to sort of give you a perspective of the applied use cases of AI. In this case, there are three big categories of how we use not only AI, but the generative AI within our ecosystem. What we mean by the ecosystem, we are referring to the UN ecosystem, yeah, in this case. The generative AI is definitely helping us from the content creation perspective. We are using AI for not only for our translation needs. Right now, you can see the entire meeting is currently being recorded. The transcripts, once we enable the transcripts, we can summarize the meeting, we can capture the minutes of the meeting, we can draft proposals using the AI tool. And we are also reviewing the contracts and making sure that the reports that we are generating has error-free kind of report. So the content creation component is a very, very helpful applied AI use case that we do see come through within our ecosystem. And the second, and it is one level above the maturity of the content creation, what we see is that, hey, now that we have the content that is available to us, how can it help us make better decisions, drive insights in with the content that we already know? And how can we have this kind of a synthesis of information that will enable us to take the insights that we can generate from structured to unstructured content, and how can we bring that level of business enablement is where the category of insights generation comes into play. And at this moment, we do have certain use cases that, for example, we are working with 12 partner agencies in order for them to extract insights from the multiple HR policy documents that is stored in our UN Knowledge Repository. So some of these use cases are direct application of AI, so we would categorize them as insight generation. The third category, which is the most popular category, which we call as the information retrieval systems, is the enablement of ChatGPT or the chatbot, and what we call in the traditional approaches as the conversational Q&A on and documents from an internal repository. Yeah, so these kind of big categories of applied use cases is what we see as widely popular and widely used, and it is an interesting challenge for us also within the UN ecosystem to see, hey, how can we not only adapt but leapfrog in our adoption, like, because there is this approach wherein, like, you know, how can we work backwards, wherein we can show and tell few things that can be achieved using AI. So I think UNICC, our team are currently focusing on that kind of applied use cases, the things that we can bring to the user community in a shorter period of time by creating reusable sort of components that within the models that we are working with right now. Yeah, an example of that is the recent chatbot that we created, where you can see that this chatbot sits on huge knowledge repository of our internal knowledge base, and you can see that this chatbot is not only contextually trained, it also responds to the knowledge in a different content, in a different language also. Like, you can see that the same chatbot can respond to a question that is not only posted in English, but also to a non-English content, because we do have 6 official languages within the UN ecosystem. So we are wanting to make sure that we are testing these approaches in multilingual contextual capability also. So chatbot and leveraging ChatGPT is one of the most sought after use case that we do see come through within the UN ecosystem. Yeah. Without further ado, this is the big picture of where are we heading? Where do we see we as UN drive more value by using AI, and how can we sort of drive impact? AI can allow us to not only directly impact the SDG goals. Some of the use cases that you see here, where we are using AI to increase agricultural productivity, identifying and monitoring poachers, and also the species in the ecosystem, and also identifying illegal fishing through pattern recognition using a AI-based software. And also, how can we improve the efficiency of clean water provisioning across the board, and also in the global south. So some of these use cases we do see will bring a lot of impact that we actually took a longer time to drive traction. Yeah, and of course, as Andres mentioned, all these AI use cases do bring challenges coming to us. Yeah, what we see as challenges or the risks or that comes to our table is some of these tools we do see that they lack transparency. What we mean by lack transparency is that some of these models or the choices of tools that we choose in solving for these problems are essentially black box models. They don't have the sort of the reason to clarify how the data that you're using to train these models are being responsibly used versus what is the reason for an output or an outcome. So those are sort of, the first principles that we operate with when we are creating tools or when we are creating AI models for our user community. We start with the do no harm approach. What it means is that the transparency comes first, responsibility of handling our own data sets on how we train these models comes first. Of course, accuracy is a very, very important metric and a component that we do consider, but there is also an equally important component of bias. So we make sure that some of these models that we are using in our decision-making process has the component of human in the loop. What we mean by human in the loop is the human has the right to override the decision of the AI model that we are creating. That way, we make sure the models are not only bringing the biased sort of responses, we also make sure that the bias has the component where we can interject, where we can block, and we have the decision-making power to comply with the output that needs to be sort of reviewed or assessed and evaluated by a human. And the intellectual property of the components that we are creating within the UN ecosystem, we also operate with the principles of open source comes first. Yeah. So making sure that the AI watermark is being considered, and also the data classification and the data usage of privately available information is not fed to these models. Yeah. And of course, cybersecurity, the security of our data and the protection of our data, the privacy of the components that we use within our UN data sets is also one of the priority for us. And of course, just because there is AI available to us, we don't want to be using AI for problems that need not have AI to be used to solve for these problems. What we mean by that is some of these solutions that we create, we have to have the sustainability component in mind. What I mean by that is, as Andres rightly pointed out, you don't need models that are trained on internet. You don't have to recreate them. There are things that you can actually leverage, which is out there. But the biggest problem of having AI models within our ecosystem is, how do we sustain them? How do we maintain them? How do we make sure that these models are continuously being assessed, continuously being evaluated for our own needs, is what we mean by sustainability. So see, these are some of the sort of trending challenges that we see within the applied use cases of AI use cases. And I think that concludes our discussion and our thought process that we wanted to share with all of you.
Thank you very much, Mr. Fortino and Anusha. And I leave actually the floor to Ilaria for any questions that be raised in the chat. Ilaria, any questions?
Thank you, Franca, and thank you to our presenters. Yes, we have a couple of questions already. So the first one is from Timothy, saying, what are some of the considerations to make when transitioning into AI as an organization, speaking from an information security point of view, as well as choosing which model to implement?
Andres, do you want to go first?
So, yes, I certainly can address that. I usually have 3 or 4 models available to me, and I may start with one that I'm very familiar with, say ChatGPT from OpenAI. And if I find that it gives me a good result, then I stop there and I accept that result. If I find that it's either slowing down and it doesn't give me a good result, or it's going off the rails, I might want to go over to another model. My next choice would be, say, Anthropic's Claude. I find Claude for certain topics like text generation much more succinct. It's much more to the point. It's much more capable. So I would switch from one model to the other. And I use the maxim trust but verify, which means if I get an answer from one machine, I don't trust it. I may go and ask the same question to another machine and see whether the two give me similar answers. Then I feel more comfortable. Kind of like what reporters do to get two sources before they go out with their story to the public, right? And that works very well for me. I trust. So 2 or 3 models is what I suggest you invest in, because you can't trust these models 100% right now. So you want to have other ways of getting to the same answer. Always challenge the model to tell it, are you sure this is right? And that's important. Trust but verify. And the other is that you can be very sure when you have an objective analytic question, ask for data analysis, it almost always gives you correct answers. But when you have subjective questions, it's opinion on something, rate or grade. Like for grading, I would not use it for grading students' papers because I find that it has many, many biases and flaws. So far, it can get better. New versions might come out and be better, but right now, certain things I know what the limits are. So the only way to do this is test yourself to see under what circumstances and which models give you the best results. Like I said, I found ChatGPT, Anthropic, and Google's the Google model, Gemini, right, which is now up to be. They're all pretty much capable and produce pretty good results, but they all have their strengths and weaknesses. So having several and test it out to see which one gives you best result under certain circumstances. ChatGPT is much more chatty. So when I put in a transcript of a Zoom meeting that is hour to hour long, and I wanted to summarize it for me, ChatGPT gives me a very detailed summary. Claude is much more, succinct. It gives me a very short one. I said, elaborate more, because it wants to be brief. So it has its own, each one has its own personality and peculiarities. I hope that has helped.
And Timothy, also to add on to Andres's response, what comes first from an information security standpoint is for you to classify your data ahead of time. We are not using sensitive data or data that is private to be used in training of these models. If they are used for those purposes, you got to be very, very careful, and on also the evaluation and the assessment methodologies needs to be looked at for our standards, and making sure that there is transparency around how the approaches of the data has been used. So those are the sort of checkpoints that we need to consider before implementing these models.
All of the companies that run these models, the foundation models that are available to the public, they claim that if you put in private information, they say, well, our contract with you is that we will not use it to train future models with that data. But it's once you put it up in the cloud into their hands, you really don't have any assurance unless you're under a service level agreement. You lock it down, you're paying a lot of money, and then you can take them to court because they violated it by then using your data. And even then, it's hard to prove that they did use your data or didn't use your data. So that's hard. So I would be careful with very sensitive data, but anything public, I would, have no problems with it. And anything that is not as sensitive, you want to use it as part of analyze this for me. A transcript of a meeting, I would be comfortable with that. They would not necessarily use that. But, confidential memos on strategy and things of that nature that are still being developed, it wouldn't leak to the internet, but they might use it in the future as data from the UN that we can use it to train future models. And you don't know if they're going to abide by their public pronouncements or not. So I would be concerned.
And those are the instances where we want to make sure that if we are using AI models for your enterprise workflow, you got to only use the enterprise version of these AI models, not the publicly available open source versions.
Okay, thank you. Next question is from Carlos. Hello, thank you very much for organizing this event. I would like to know, how is UNICC as an international organization contributing to the development of standards and policies for AI?
Thank you for the question, Luis, Carlos. We are a part of multiple work streams in the working groups where we are sharing our lessons learned and on also contributing to creating standards and frameworks when it comes to the UN internal ecosystem.
Thank you, Anusha. Next question is, can you provide more insights on the cybersecurity risks associated with AI?
If
Well,
I may,
yeah.
sorry, if I may, I let you answer. I saw that there are a few around cybersecurity, a few questions around cybersecurity topics. So it seems to be a quite hot topic. So we may think of actually you dedicate a webinar on this. What do you think, Anusha and Dr. Fortino? Because it seems to be, you know, data privacy, data storing, cybersecurity in general, the use of AI seems to be quite a hot topic. So maybe even inviting our colleagues from cybersecurity, it might be.
I agree, Franca.
Sounds like a good approach because it seems to be a hot
Please,
topic.
I leave the floor to you.
I agree. Thank you, Franca. Thank you for bringing that up. And I think that kind of gives us a good segue to our next webinar series, perhaps. So we will make sure that we will respond to all your questions. And Franca and Ilaria, perhaps Andres and I can take these questions offline and respond to the audience to make sure that we have some time to close the webinar today.
Okay, so thank you very much, everybody. And definitely we will look into the questions, and these are inspirational, as I said before, for any other topic that you may want to see presented. So feel free to keep, feeding the chat of the webinar with any additional question you may have or any additional topic you would like us to cover when it comes to innovative technologies, and we will make sure to bring the right expertise on board for the webinar. Thank you, everybody. I see a lot of participation, very nice numbers. And thank you again to Dr. Fortino and to Anusha for bringing their knowledge. It was just a touch base. So it's just the beginning of our journey. I hope to see you again, everybody there, and deep dive into this, interesting conversation that whether we like or not, it's part of our life. Thank you again and enjoy the rest of your day.
Thank you. Ciao, Franca. Thank you, colleagues.
Thank you.
Thank you.
Bye.
Thank you.